Hi, this is David Voss, CCIE 11372, and in this video you're going to learn how to troubleshoot IPv4 addressing. Now, that being said, this video seems like it might be a simple video to grasp, but you'll be surprised at how much you learn. This video also assumes that you have a basic understanding of IPv4. In this video, we're going to cover how to troubleshoot IPv4 addressing and then give you a few challenge scenarios. So let's begin. An IPv4 address, as you know, is made up of two parts. First is the host portion, and next is the subnet portion. And it's obviously very important that all devices in the same subnet share the exact same subnet information. That is the subnet portion. So if they're not exactly the same, the PC could end up addressing the layer 2 frame incorrectly and sending the packet in the wrong direction. So let's take a look at a sample subnet here. When PC1 wants to communicate with PC2, it'll do a DNS lookup of the IP address for PC2. The IP address is 10.10.10.20, and that is what is returned. Now PC1 needs to determine whether PC2 is located on the local subnet. That will help it determine whether the frame will have the MAC address of PC2 or the MAC address of the default gateway. So PC1 determines the subnet portion by its comparing its IP address to its subnet mask in binary as follows. And as you will see here, all of the ones in the subnet mask identify the network portion. Now PC1 then compares the exact same binary bits to those binary bits in PC2's address as follows. Now, because the binary bits are the same, PC1 can then conclude that PC2 is on the same subnet. Therefore, it can communicate directly with it, and it does not need to send the data to a default gateway. PC1 will create a frame with its own source MAC address, and then the MAC address of PC2 as the destination. Now, consider what occurs when PC1 needs to communicate with the mail server at 192.10.10.1. Again, it does a DNS lookup for the IP address of the mail server. The IP address of 192.10.10.1 is returned. And then PC1 determines whether the web server is located on the same subnet. So PC1 does this by comparing its IP address to its subnet mask in binary as follows. Now PC1 compares the exact same binary bits to the binary bits of the mail server as follows. And by doing this, PC1 then concludes that the mail server is on a different subnet because its bits are not the same. Therefore, in order to communicate with that mail server, it sends the data to a default gateway. PC1 will then create a frame with its own source MAC address and the MAC address of R1, router 1, as the destination. Now, if PC1 is configured with the wrong subnet mask, then everything can start going wrong. PC1 will do the same check as before. It will compare the binary bits between PC1 and PC2 for comparison to make sure they're on the same subnet, and it will figure out that they're not. Therefore, since it cannot communicate directly with it, it sends the frame to the router so that the router can route that packet. But the packet obviously does not need to be routed, so in this scenario, we're going to have communication issues, simply because the subnet mask was inappropriately specified. Now, obviously, having an incorrect subnet mask can cause major problems, and probably is much more likely. But also, obviously, having the wrong IP address assigned could cause issues as well. You can assign an IP address off a wrong subnet and thus cause problems. So, very simply, this is going to be on the endpoint to view the IP information on a Windows box, for example. You would type in ipconfig to view the IP address information. And then if you want to view the IP address information on a Cisco router, you would simply do show IP interface and then the interface you want to look at. You could do show IP interface brief as well. Now, as a reminder, the reason Cisco added this to the CCNP exam was to make sure that you had this basic knowledge. So these scenarios may seem basic. So in this first scenario, PC1 and PC2 are reporting problems communicating not only with each other, but other hosts on the network. See if you can spot the multiple issues. As you can see, PC1 and PC2 aren't even on the same subnet. PC1 is on /25, which takes up IP addresses from 0 to 127, and then PC2 is on the /25, which takes up IP addresses from 128 to 255. That being said, both of them have a /25 subnet. The default gateway is a /26. So there's going to be communication issues all around. So those are your two issues for this one. Now, for the next issue, both PC1 and PC2 cannot communicate with a server across the wide area network. You tell me why. And as you've undoubtedly spotted here, the server across the wide area network is on the same subnet as PC1 and PC2. So when PC1 or PC2 receives the IP address for that device, it's going to think it's on the local subnet, and it will never even bother to send it out to the default gateway. So here's what you've learned. You've gone back to basics, which is what Cisco wants you to do for the CCNP exam, to learn how to troubleshoot IPv4 addressing and subnetting. So you've looked at a bit level as to how things work. Now, obviously, when you're troubleshooting, you don't have to look at things at a bit level, but you do need to understand how the router is actually looking and comparing and making decisions on how to know when to forward a packet locally or when it needs to forward it onto a gateway. Then you receive two relatively easy challenge scenarios. Hopefully you solve those problems relatively quickly. If you didn't, if you struggled with any of this, really it would be the time to go back to the CCNA studies and get your solid foundation in, because that's why Cisco added this element to the CCNP exam, was that they found there was too many people who didn't know some of these basic things and they were struggling in CCNP. So make sure you have this down, and if you don't, again, feel free to revisit the CCNA material and then come back. Good luck in your studies.